What up, homies? This is Alec Bo with Code with Bo. Today we're going to be talking about Python lists. And what a Python list is it's a data structure that comes built in with Python. It's native to Python. I'm going to go ahead and show you an example. So you, like any other variable, you give it a name, the list a name, you use the assignment operator, and then you put in these two brackets. And so we could declare an empty list like this, or we can put some data in it. But we're gonna go ahead and put some data in it. And so we have some integers up to the value of 4. We're gonna go ahead and push enter, create the list. The way you access these individual elements in the list is you use what's called indexing. And like most other programming languages, Python begins indexing with the index value of 0. And so this 0 is going to represent the first element in the list. If I put 1, it would be the second element. If I put 3, then that's, or if I put, 1, it'd be the second element. If I put 2, it'd be the third element. If I put 3, it'd be the fourth element, so on and so on. So we're going to go ahead and do that so you can see that that right there is indeed that first element in the list. Something else you can do in Python with Python lists is you can do list slicing. And so you can take whatever piece of the list that you want and create a separate list for it. And so what you're doing right here is you're starting at the value of 0, right, the first index, and you're going to go 0, 1 to 2. But you're not going to include, this 2 is non-inclusive, so it doesn't include that 3, and you'll go ahead and see that right there. And so what we can also do is we can make a second list out of that little slice that we took. So we can hit second list right there. Actually, I guess we can't do that. Let's see. Equals, forgot to do this little part. And so now we're going to print example list, print second list, and there you go. And so right there, I just forgot to put the name of the list we were indexing, and so that's how you do it the correct way. And so that's kind of the basics of just declaring a list, what it is. So let's go into some of the things that you can do with a list. And for that, we're going to go over to the Python docs. And so right here, these are some list functions and some methods that you can use on them. So list.append is how you would add a value to a list. So we're going to go right here. We're just going to say second list dot append. We're going to add the value of 4. We're going to hit print second list. And so you can see right there where that value was added. Something else you can also do is list, they don't have to be of the same data type. And so I can put in a string to the list. And we can go ahead and print that, and you can see right there. And so you can put in integers, you can put in floats, characters, strings, any sort of object, any sort of abstract data type. This can go into the list. And then we can go into insert. We can insert an item at a given position. And so we'll go back to the first list. The list dot insert. And we're going to say, we're going to put in the index. We're going to put in the index. We'll just put 3. We're going to insert new item. Print. And then there you go. So you can see where the new item was inserted due to the insert method. We also have the remove method. So we can hit dot remove. And we can do, let's see. And there you can go where you see it was popped out. And then, so we can also come right here. And we also have some other methods. We also have list.pop, which the difference between remove and pop is remove looks for the value, while pop looks for the given position in the list. And so there's also the clear method, the count method, which will return the number of times x appears in the list. And then there's the sort method, the reverse method, and the copy method. So we can use the reverse method to reverse the list, or we can simply use what we learned up here, slicing. And so let's go ahead and do that. Example list. And so you can see where we printed the list backwards. And I'm going to go ahead and break this down for you. So right here, in between or in front of this first colon is where you would put where you want to start the slice. This is where you would want to end the slice. So whenever you leave that blank, it just assumes you want to start at the beginning and that you want to go through the whole list. And with this right here is the counter, and so that tells the list how many values to pretty much skip by. So we're telling it to go by -1. So it's going to start at the end of the list. And so you can see if I just did the index for example list -1, it's going to return that 4 because that's the ending value on the list, and it's going to go backwards by -1 each time. So we can also do this, and I'll show y'all. I'm going to put -2, and it's going to start from the back. It's going to start from the end of the list and go backwards by 2. And so you can see where it only printed these two values right there. And so, like I said, lists in Python, it is a it's a standard data type that comes with Python. It's native to Python. As you get more into deeper into your programming and software engineering journey, you're going to learn more about different data types, and some are going to be more efficient than others. So Python lists are actually not going to be the most efficient data type. A lot of people will use alternatives. They'll use what's called a Numpy Array, or they'll make their own data structure like a linked list or like a stack. And the reason why it's not the most efficient is something that's fundamental to Python. Python is an interpreted language, and it's written in C. And so we're going to go ahead and look at this over here. And so whenever you declare an integer in Python, so like let's say we're declaring an integer in C, right? So you simply declare it because it is because it's statically typed. You declare it like this. So the compiler automatically knows that you're using an integer, compared to Python, which is dynamically typed. So we don't have, if we want to declare an integer, we don't have to type in integer. I can just do num equals 1, and the interpreter will know that's an integer, but it knows it's an integer after it goes through this process, right? Where it goes to a Python object, and that object head has an attribute, and we assign the value of that integer to that digit attribute. And so you can see there's a couple more steps involved than just simply declaring an integer like you would in a statically typed language. And so this part breaks down addition, right? And so let's say right here we assign 1 to A, 2 to B, then we add them. So since it is a statically typed language, that's a pretty straightforward process, right? Int 1 is to A, int 2 is to B, and then you just do a basic addition operation, and then you assign the result. And so this is going to be the Python version of that. You don't do the data type declarations whenever you initialize the variables. But look at how much more complex this process is. To assign 1 to A, you have to set A. You have to A is going to point at a Python object, which is going to have a type code, and that type code is going to be set to integer. And then you're going to set A, the value, to 1, right? And so that's already, way more work that the computer has to do compared to this right there. And that process is going to be pretty standard in everything you do in Python because of the way it is fundamentally being an interpreted language written in it's an interpreted programming language that's dynamically typed, and it's written in a statically typed language. So Python is written in C. And so whenever you hear people say Python is slow, that's going to be one of the reasons why. And then it just kind of repeats that right here. Python is interpreted and compiled. And so whenever you look at that relative to list implementations, so like it was saying, there's the extra type info layer in Python when moving from a C integer to a Python integer. And so this is going to be an example of a Numpy array right here. So a Numpy array is a Python object built around a C array. It has a pointer to a contiguous data buffer of values. So it points to the data right here, 1, and then this would be all the data right there stored in that array, while a Python list has a pointer to a buffer of pointers, which points to a Python object, which has a reference to its data. And so, like we saw earlier, right, you have the variable, and that's going to point to a Python object, which is going to have a reference to the data type and the data stored. And so you can already see how much more inefficient this looks compared to a simple array implementation, right? And so you see where each of these locations in memory points to a Python object, which goes through these operations right here just to assign an actual value to a specific data type. And it does that not just for integers, it does that for strings, for floats, for whatever. It'll do that because that's just the nature of a dynamically typed programming language. And so that's kind of a little bit of background on lists. So you're asking, well, why are we learning this if it's so slow? It is a good place to start with your data structures. I'm not going to say you're not going to use them, but coding is one of those things to where you kind of learn. I don't want to say that you learn the easy ways to do things first to kind of prepare you for the harder ways that are going to come, and that just makes the whole process of learning programming easier. But what I would do is I would do a little bit more research on lists, right? You can come over here to the docs on Python, and they have a section specifically to data structures where it goes over all the lists, right? Using lists is stacks. Stacks is another type of data structure. Queues is another type of data structure. It shows you how to do that. And so you can get broadly familiar with it right now. Practice on it. Go through these. Learn some new things. Maybe build something with them. And then next week, I'm going to show you how to, or not next week, but next video, I'm going to show you how to iterate through lists and what a list implementation would look like in an actual program where it has a little bit of functionality. But until then, this has been Code with Bo. Be sure you subscribe to my YouTube channel for more tutorials on not only Python, but also Swift and C++. This video is a part of our Intro to Python series. Go ahead and subscribe if you are learning to code, or even if you do know how to code and you want to come back and review some of those things you learned on in the early days, just to kind of get that refresher and solidify the understanding that you do have. But yeah, till the next video, y'all have a good one.